In the next couple of videos, we see the use of Pythagoras theorem in the study of vectors and its components. Here we choose the coordinate system of representing vectors in a plane. Now, this is a square rule sheet and we take this direction as plus x direction and this direction as plus y direction, and where these two intersect we call that as origin O, and its coordinates are taken as 0, 0. Now, with respect to this origin 0, 0, A is a point that has coordinates plus 3 and plus 4. Now, the directed line segment that joins the initial point O here to the final point A is a straight line drawn from O to A, and we show the end point with the tip of the arrow just touching the point A. And how do we represent it? We write vector OA like this. So we read it as OA vector OA. Here the first point O has coordinates 0, 0 and the final point A has coordinates plus 3, plus 4. Now the rule of the game to find the x component of the vector OA and y component of the vector OA is almost the same as the rules for finding the x coordinate of the point A and y coordinate of the point A. Now the rule of the game is, starting from the initial point O, in order to reach the final point A, we have to move either along x-axis or along y-axis. So, starting from O, in order to reach the point A, we begin with moving along positive x direction, and we move 1, 2, 3 units and reach the point E1, and we say the plus 3 units is the x coordinate of A, or the x component of vector OA is simply plus 3. And we represent it like this. See, this is vector OA and the initial point O has coordinates 0, 0 and the final point A has coordinates plus 3, plus 4. Now the x component of vector OA, we write OA sub x is equal to simply the x coordinate of the final point A, the x coordinate of the final point A, which in this specific case is simply plus 3. And the y component of vector OA is equal to simply the y coordinate of the point A, which is plus 4. The y coordinate of point A is simply plus 4. Therefore, the y component of vector OA from E1 to A is simply plus 4 units. That's what I have indicated here. The x component of vector OA is plus 3, which is the x coordinate of final point A, and the y component of vector OA is plus 4, which is simply the y coordinate of the final point A. Now, how do we find the magnitude of the vector? Magnitude of the vector is simply the length of the line segment from O to A. Now, we see that we have a right angle between sides OE1 and E1A at E1, and therefore in the right angle triangle OE1A, OA is the hypotenuse because it's opposite to the right angle. And square of the hypotenuse, that is square of OA, has to be equal to square of OE1 plus square of E1A. And OE1 is simply the x component of vector OA. So OE1 square is square of x component of vector OA plus E1A. E1A is y component of vector OA, and E1A squared is square of y component of vector OA. So we know x component of vector OA is simply the x coordinate of the final point A, x coordinate of the final point A. So we have plus 3 whole squared plus y component squared means the y coordinate plus 4 here, its square plus 4 whole squared. We know this is 3 squared is 9 plus 4 squared is 16, and therefore OA squared is 9 plus 16, 25. We know that is 5 times 5 or 5 squared or square of 5. Therefore, the hypotenuse OA, also called the magnitude of the vector OA, is simply square root of 25, which is 5.